Alright, well, alright, hey everybody. So, welcome back. So, we're going to be going over Part B today. So, or Part B for Homework 1. So, in this part, what we're going to be doing is we're going to be taking experimental data. I'm going to just do my imports real quick. Got that. Now let me grab our link here. So what I'm doing now is I'm just retrieving the data and storing it in a data.csv file using wget. So now if you read that, CSV, let me fix the header on that. Equal temp and pvap. Yep. Alright, so we got our data frame object. And that's just storing all the stuff that's in the data.csv. So it's the temperature in the first column and the vapor pressure in the second column. To show that, let me go and make a figure. X equal df.temp, y equal df.pvap, big.add trace, oh no, hold on, mode equal markers, and if I show that, you're going to notice that it has that curve upward you see with a lot of vapor pressure curves. Notice up here, let me just set up a layout. Font layout. Let's go template equals blot dark. Width, let's do 600. Height, let's do 600. And then show legend, set that to false. Makes sense. Sure. Help if I actually set that. Yeah, there we go. So, on the x-axis we have our temperature, our y-axis we got our vapor pressure pascals. So that's what you look like currently. So now let's actually get to solving our pvap equation. So define amp1. Exponential of A minus B divided by T plus C. So that is our Antoine equation. That's what's going to turn the vapor pressure. So we have that defined. So let's get to actually calculating those three coefficients. So first, let's set up our design matrix, which we'll just call A. I'm going to use NumPy. And so if we go back here, you look at our first column, our 5 ones. Go up a little bit. Where is it at? Right here. So our phi 1 is just going to be all our temperatures. Wrong one. So df.temp. Now for our second one, like I said during the actual video, this is going to be all ones because this is just a constant. So np.1, so like df.temp. And finally, our last one is just negative np log of df.pval. And then our result matrix is just going to be our temp multiplied by the log of our vapor pressure. Like right here. I'll do df dot. So, now, our result is going to be using linear algebra package of NumPy, np.linealgebra.solve, a dot transpose by a dot transpose multiplied by b. Because remember, right at the very end, we're talking about this, where that transpose is going to get us to 3 by 1 for our b, and our square is going to be the a transposed by a. So that's why we got to do that there. So if we run that, we get 3 values. But remember, this middle value here, we have to do an extra operation to it. Because up here, where is it at? This C2 is not the same as B. To solve it, we got to use this equation. So what I'm going to do is I'm going to do A, B, C. I'm going to do B equal to A times C minus the current value of B. And then what I'm going to do now, model lambda T Antoine equation T A B C. So now what I can do is, let me save myself a little headache. Do raw trace. What's that? Replace that. Trace. Sure, yep. Fig equals go dot figure. Layout. Trace, raw data, not raw data, raw trace. I just wrote that out. Fig.add trace, go.scatter, x equals df.temp, y, or we actually, before I do that, we need to make t-plot, linspace, from df.temp.min to df.temp.max. Do 100 data points. Dig.scatter. X equals t-plot. And y is model for t-plot. So, with our results up here using Lagrange.solve, you can see the curve it's fitted quite nicely. And then just show you the results. Our A is about 23.55. Our B is about 4080.08-ish. And our C is negative 34.38. So that's our current values for those. Well, that's the values we found that fits this model the best. So in the next part, we're going to be talking about how to do this a different way. So I will see you guys for that in just a little bit.